And now, Kyle, as per your request, the changes of matter, physically and chemically, that is. Why don't we start with physical change, which is a change in state, shape, or size without forming a new substance. A change in the state of matter is a physical change. For example, when water changes state, it looks and feels different, but it is still water, whether it's ice, liquid, or vapor. Let's run with this, shall we? When you grind peanuts, you get peanut butter. The size and shape have changed, but you still have peanuts. Remember, a change in size or shape is a physical change. No new substance is formed. Other physical changes include mixing together two or more kinds of matter, or separating matter into the different parts, as long as no new substance is formed. Most of the objects around us are not pure substances, but mixtures. A mixture is two or more parts blended together. Yet, they keep their own properties and do not turn into a new substance. In some mixtures, it's easy to tell that each type of matter keeps its physical properties because you can still see the individual parts of the mixture. Examples of this would be salad, spaghetti, tacos, and trail mix. In other mixtures, the parts are hard to see, like sugar or salt mixed with water. Also, in a mixture, you can put the substances together in any amounts. For example, tea can be either very strong or very weak. Mixtures can be made of solids, liquids, or gases, and can be made with a combination of different forms of matter. Air is a mixture of different gases. Mixtures can also be separated using their physical properties like size, shape, color, volume, density, and state. This is called a physical separation. It's important to remember that substances that make up mixtures keep their physical properties as well as their chemical properties. Some mixtures are not as easily separated. These hard-to-separate mixtures are called solutions. A solution is a mixture in which substances are completely blended so that the properties are the same throughout. The substances are mixed evenly, so they stay blended. If you put a spoonful of sugar into a glass of liquid water and stir, the sugar seems to disappear, and the glass still contains a clear liquid. The sugar and the water form a kind of mixture called a solution. Although you can't see it, you can tell the sugar is in the water because it tastes sweet. When the water evaporates, the sugar will be left behind, and you can see it again. People drink a lot of types of solutions, like tea, coffee, fruit juices, and soft drinks. When one material forms a solution with another material, we say it dissolves. The substance in a solution dissolve or separate into their most basic particles, molecules that are too small to be seen. As sugar dissolves in water, molecules of solid sugar are pulled away from each other by water molecules. Very quickly, the sugar molecules spread to all parts of the solution. You can no longer see the sugar because the very small sugar particles are mixed evenly with the water particles. Unlike the mixture granola, that might have 6 raisins in one spoonful and 3 in the next, any part of the solution is identical to any other part of the solution. Some solids dissolve in water and some do not. Solubility is a measure of the amount of a material that will dissolve in another material. For example, sugar is soluble in water, but ground black pepper is not. Try stirring sand into water. While you're stirring, the sand mixes with the water, but does not dissolve. When you stop stirring, the sand falls to the bottom of the jar. The solubility of sand in water is 0. No amount of sand dissolves in water. Liquid solutions are usually transparent. They're evenly colored, and they can never separate into layers. Compare the mixture of oil and vinegar, as in salad dressing, to a solution, like this drink mix. Also, solutions don't have to be liquid. They can be solids and gases, too. In the sugar and water solution, a solid, sugar, was mixed with a liquid, water. In a bottle of soda, the gas carbon dioxide is dissolved in or spread evenly throughout the liquid. When you lift the top off the bottle, you can see thousands of bubbles of carbon dioxide gas start to rise through the liquid and into the air. Mixtures of metals are solid solutions. Brass is a solution of zinc and copper. It is made by melting two metals together. Gases can form solutions too. Air is a solution of several gases. Physical changes can sometimes be easily reversed, but not always. Melting an ice cube can easily be reversed by cooling until it freezes again. Stirring sugar into water can be reversed by letting the water evaporate. On the other hand, it would not be so easy to get peanuts back once they were all ground up.
So, if a change seems easy to reverse, it is more likely to be a physical change.
But not all combinations of matter can be separated physically into their parts.
Well done.